So we're just going to finish up lesson 1.4, and I apologize if you hear me coughing throughout this lesson, just not feeling the best right now. But yeah, so when we took up lesson 1.4 on Friday, we were talking about transformations, and the ones we covered so far are the vertical translation is what we did first. So this K right here, that was the vertical. And then the next one that we did after that is we dealt with the horizontal, the H value. So this H is the horizontal. Going back up to the top, you see that there's only three variables. So here, H horizontal, horizontal. The only one we have to deal with today is this last A value. So go down to the bottom of the lesson. All right, so we've covered all of this. Exploring the role of A. Complete the values, complete the following table of values, and then graph the given functions below. So as a recap from Friday, this one right here, this first one is our parent function. So what we're doing is we're comparing the other graphs, these ones right here, to the parent function. Let's just put the parent function's points that are given there in ordered pairs so we can easily plot them. So -3 and 9, -2 and 4, -1, 1, 0, 0, and we're just reading off the chart here, writing the x's and the y's, 2, 4, 3, 9. So let's plot these ordered pairs for the parent function. And so parent, we'll do it in green. So we're plotting the point, -3 and 9. So this is -3 right here, and then 9 would be, I guess if this is what, 9, 10, 11, okay, so there's 10. So -3 and 10 right there. Oh, sorry, 9. -3 and 9. -2 and 4 right there. -1 and 1. So -1 and 1. And then we have 0 and 0. 0 and 0. 1, 1. 2 and 4. And then 3 and 9. So there is our graph of f of x. Graph of f of x. So now our goal is to plot g of x and h of x. So let's do g of x in red. So mathematically, this a value right here, this is 2 multiplied by x squared. So do the x squared first, then the multiplying by 2 for all of these given x's right here. So we're evaluating g at -3. So that's 2 times -3 squared, which is, I'll write this one fully out, 2 times 9, which gives you 18. So then g of -2 is 2 minus 2 squared. If you do the math there, -2 to the power of 2 is 4. Multiply that by 2, that gives you 8. G of -1 to -1 squared. That would give you, let me zoom in here. That'd be 1 and 2. G of 0 is 2 0 squared. Or just 0, because 0 times anything is 0. G of 1 is 2 times 1 squared, or 2. And then g of 2 is 2 squared, giving you 4 times 2, 8. And then 3 is 3 squared, 9, 18. So let's write our ordered pairs again. So we're evaluating this at -3 on the x, and we calculate it to be 18 on the y. this was minus 2 on the x, 8 on the y, minus 1 on the x, 2 on the y, 0 on the x, 0 on the y, 1 on the x, 2 on the y, 2 on the x, 8 on the y, 3 on the x, 18. So let's plot those points in red, those ordered pairs right there. So first one is negative 3 and 18. So 17, 18, that's right up here. Negative 2 and 8, that's right there. Negative 1 and 2, that would be right here. And then we have 0 and 0, so right at the origin again. And then we can just mirror all our points. So 2 and 8, and then we have 3 and 18 right up here. So we can kind of see this is slightly different than the others, because if you go back up to the previous ones, you'll notice that the vertex was always in a different spot. But that's not the case here. When we're changing the a value, the vertex, see how these vertexes were always changing? Like here it's over here it's over here now. Well, that's not the case here. The vertex stays exactly where it is. But notice how the points are much higher. That point is all the way up there now. All the way up there now. But we have not vertically shifted or translated at all. We've done something else, which we'll talk about in a second. But just notice how this is much steeper. Okay, I'll use that word steeper. So let's do the last one for h of x. Again, the same math applies here, okay? We just have a negative 1/2. So this is written as negative 1/2 times x squared. So h at minus 3. And it's okay to just take your calculator out and run through these numbers. But it's negative 1/2 times minus 3 squared. So minus 3 squared is going to give you 9. And then negative 1/2 is going to give you negative 9 over 2, which is also negative 4.5. And you can put it in a decimal just so we can plot the point, okay? So h at minus 2 is minus 2, negative 1/2 minus 2 squared. Minus 2 squared would be 4. Times that by negative 1/2, that would be minus 2. H of minus 1 is negative 1/2 minus 1 squared. So that would give you 1. Times it by 1/2. Again, it would give you minus 1/2, but put that into a decimal so we can plot it. 0.5. H of 0, negative 1/2, 0 squared is 0. H of 1, negative 1/2, 1 squared is minus 1/2, decimal, 0.5. And then h of 2 is minus 1/2, 2 squared. So 2 squared is 4, times that by 1/2 is minus 2, so essentially half of 4. And then you have h of 3 minus 1/2, 3 squared would give you 9 over 2, negative 9 over 2. And once again, you get minus 4.5. So here are ordered pairs. When we plugged in the point minus 3, we got negative 4.5. Let me clean that up, make that look nicer. 4.5. When you plugged in the point minus 2, you got minus 2. When you plugged in the point minus 1, you got 0.5. Oh, it should be negative 1/2. Negative. This should be a negative here. Negative. And that one make this one negative as well right here. Negative 0.5. Alright. And then this is 0, 0, 1, negative 0.5. And this is 2, minus 2. And this is 3, minus 4.5. Okay, so let's plot those points in green. Sorry, I'm zooming out here. We are going to have the first point at minus 3 and negative 4.5. So let's put these on the chart here. Negative 1, negative 2, negative 3. Let's call this line right here minus 4, just the end of it. So really we're going to be off the graph, because if this is minus 5 right here, 4.5 would be like halfway between it right there. So plotting the point negative 3 and negative 4.5, that would be right here. Again, we're off the graph, so the scale is ever so slightly off. So negative 3 and negative 4.5. Then we have negative 2 and negative 2. So that's right here. Negative 2 and negative 2. Then we have 0 and 0. Again, the origin is the same. Oh, I did this one in green. I should have done... Okay, that's fine. Actually, I'll plot this one in blue, just so we can see the contrast. So, blue, blue, and then negative 1 and 0 right here. Blue, 0 and 0. And then we've got negative 1 and 0.5 there. And we can just mirror our points, plot them out, and there is our graph. Okay. Need the point right here. There we go. That's h of x. All right. So notice the graph here on this one. All of these ones right here, these above ones, these are all opening up. And if we notice something, look at g of x and h of x. Well, here, g of x is opening up, and here it's because the a value is positive. On the parent function, this is f of x equals, yes, it's x squared, but it's really 1x squared, where the a is also positive. So they open up. But if we look over here at h of x, here, the a is negative 1/2, or it's a negative number. And notice how that causes the graph to open up the other direction. So this one right here, this opens down. The a is negative. And here the a is positive. And that's why it opens up or opens down. All right. And again, I'm going to fill in this chart, but I want you to visually see it as we're filling in the chart. So let's fill it in right here. F of x, this a value is 1. So the value of a, doing a more contrasting color, the value of a is a equals 1. Well, the vertex is the same on every single one. They're all right there at the origin. So in this case, every single one has the same vertex. Nothing changed. They're all 0, 0. F of x, so let's go back top. Direction of opening, as we just said, is it opens up. Opens up. A opens up. A is positive. And then remember, the vertex is written as h and k. So whatever value is right here on the vertex, and the axis symmetry is x equals h, well, our vertex has coordinates h and k, so here the h is 0, so you have the axis symmetry being x equals 0. So whatever the vertex is. Okay, let's fill in the next one. So g of x, in our case here, a is 2. Well, the vertex we already said is 0, 0. This one opens up because a is also positive. Well, the axis of symmetry, x equals 0, because the h is 0. But now this one right here, h, the a is minus 1/2. Okay, so this fraction also has an impact on it, okay? And we'll talk about that in a second. But right now, we're just going to say this opens down. A is negative. The axis symmetry is still x equals 0 because h is 0. All right, we're going to fill in this half right here. We're going to talk about it right on this chart below. But I just want you to visually see what's actually happening again. If you can imagine this green parabola right here being stretched or compressed, look how the blue one looks like the green one was kind of sat on, in the sense that this one right here, this blue one, looks like it was compressed. Somebody sat on it and it looks a lot wider. So it's wider or compressed. And that's because the a value is a fraction, right? So whenever the a value is a fraction, it's going to be compressed. And then if you look at the red one right here, well, it looks like somebody took the green one and pushed it in or pulled it up. Look how much higher it is. It's rising. It's pulled in and pulled up. It's like you taking an elastic band and stretching it. You notice that the elastic band would come together closer and go longer. And so this one right here is being stretched. So now let's put the actual math to these words. So if we compare to the graph of f of x, again, our parent graph, this is our parent, the graph of g of x equals a to x represents a, well, g of x was the one where a was 2, a vertical, oh, sorry, I'll put it in red because you can go back, vertical stretch. All right, I guess stretch, we're going the other word. Leather line, sorry. Vertical stretch by a factor of a. All right. And then if a is greater than 1, all right, so again, being a whole number like 2, 3, 4, it could be anything. It could also be like 4.5. The graph of f of x squared is vertically stretched. Vertically stretched by a factor of a. If 0 is less than, this means less than, this means greater than. If 0 is less than a, but greater than 0 or less than 1, the graph of fx is considered vertically compressed. And let's just talk about this for a second. In layman's terms, this just means a fraction, but not all fraction. It's a fraction where the denominator is bigger than the numerator. So like 2 over 3 would be like an example. Because 5 over 4, where that right there was bigger than the denominator, that's technically 1.25, and that is not bigger than, that is bigger than 1, right? So that does not work. But think of it as like a fraction that's smaller than 1, like a half or a third. And then the last one is if a is negative. Okay, so going back up here, you notice we had that negative half, this negative right here. If a is negative, then the graph of f of x is considered reflected, all right, in the x-axis. So imagine you like hold a mirror to this x-axis. If you held a mirror, right, you would see a reflection of the curve. It would reflect over it. And that's what that means. Reflected in the x-axis. So let's go over these. Example 1. For each function, identify the values of the parameters a, h, and k. Identify the transformations, state the vertex, and state the direction of opening. All right. So, 1, or I, sorry. Identify the values of the parameters a and h and k. Well, the number that's right next to the x squared, that right there is your a, and there it is your k, because there is no brackets on this one, so there is no h value. So in this case, our a is -4. Our h, we don't have one, but we'll still, it's 0 technically, and the k is -3. 2. Or identify the transformations. Okay, so let's talk about this a first. Remember, a has 2 parts to it, as opposed to all the other ones, right? The special thing about a, as opposed to all the other ones, is that you have this part, this is part 1, and you have this part, part 2. Okay, so a accomplishes 2 things. It talks about stretches and compressions, and also reflections. So whenever you look at an a value, you have to identify if it's negative, and then also talk about the value. So in this case, because a is negative, this is reflected in the x-axis, or you can see this as, this is also sometimes written as over the x-axis. And then a is greater than 1, so it is a vertical stretch by a factor of 4. And notice the word factor. I'm not saying unit. Factor means it's a multiple, and because this is being multiplied right here. All right. And then we have nothing to do with the h, because nothing's occurring here, it's 0. And then we now have to do with the k. Well, k is -3. So if you need to, take a second, pause this video, go up, and think, okay, well, what does k do when it's a minus? Well, k is -3, so we have a vertical shift. And again, notice how I'm using the word units now, by 3 units down. The negative makes it go down. Well, the vertex, part I, the vertex is always at the point h and k. So in this case, we've already identified h is 0 and the k is -3. So our vertex is at the point 0, -3. And then the last one, state the direction of opening. Well, we've talked about a reflection right here. And direction of opening is talking about, is a positive or negative? So in this case, we have a negative a. So to answer 4, well, the direction of opening, DOO, is down, because a is negative. A is negative. Okay. So again, pause if you need to keep looking at that, but let's move on to the next one. So here, we have all 3 of them. The a is always the one being multiplied by the x, so this right here is your a, right here is your h, and right here is your k. So if we answer the questions again, identify the parameters, well, answering the first, so maybe I'll do it in a different color. I know. A equals 1/2. H equals, remember it's the opposite, so because you see a -3 there, H is +3. and then this is k. K is 2. So the transformations, well, A talks about vertical compressions and stretches. So since A is between 1 and 0, right, it's not negative, you have a vertical compression, right? It's being compressed because it's a half. Vertical compression by a factor of 1/2. Let me just move this over. There's our first point. Second point, well, we have the h value. So remember, h's talk about moving left or right. So because, again, you see a negative here, your brain thinks, okay, well, I got to move to the negative x's. No, it's the opposite. So you're going to have a horizontal shift or translation. And again, it's negative, so that means you're actually going positive. You're going to the right by 3 units. And then the next one, you have the k value talks about being up or down. So you have a vertical translation or shift. You can use either word. Sorry, because I noticed I used shift over here. Translation up by 2 units. Stating the vertex, well, the vertex, once again, is always at the h and the k. So we've identified our h and our k. I'll use a different color so it's more. Well, in this case, our vertex is at 3, 2, because this is our h, k. That's actually 3. Sorry, I'm pretty sick right now, so I'm making a few mistakes along the way. And this is 4. And then this one, state the direction of opening. Well, we look for the sign of our a value. In this case, a was 1/2, but it's positive, so that's what determines the direction of opening. So our direction of opening, DOO, is up. A is positive. A is positive. All right, example 2, and then we're done. It's the end of the lesson. So consider a parabola P that is congruent to y equals x squared. Okay, so this word congruent, this is going to come up a lot. All right, textbook uses this a lot. Let's put a note what congruent means. So congruent is the same a value. So same a value as whatever one is comparing to, as the one is giving you, as the function, as the graph, or the function, as a graph / function given. So in this case, it's being congruent to this is the given one. That's our given one. This is our given. So when I'm looking at congruent, I'm looking at the a value. Well, in this case, that means the a value here is 1. So I have consider a parabola P. That means parabola P has an a value of 1 because it's congruent to that one. So find the equation of the new parabola that results if P is translated 2 units up and 2 units left. So again, pause and try to do this yourself. But when you're ready, we'll go on. But yeah, try and go through this yourself. So translating 2 units up. Well, 2 units up, that means k is positive 2. 3 units to the left, again, think opposite, okay? So what would you see inside the brackets if you were moving left? Well, you would expect, all right, so you have this parabola P. So parabola P is going to be, well, let's talk about the 3 units left for a second. If you're going left, you would have to have a positive 3 inside the thing, inside the brackets. because you do the opposite, okay? And then 2 units up means you're plus 2. So this is the H, this is the K, and then as we said, it has an A value. You don't have to actually show this A because it's just being 1, but this is because it's congruent to y equals x squared. So just a nice cleaner answer. It's P equals x plus 3 squared plus 2. Okay, so now part B is saying reflected in the x-axis. Well, what this part means right here is now A is negative. It's translated 1 unit to the left. Okay, so again, what is it? This talks about our H value. And again, you're going to the left, right? So you expect to see a positive number in the bracket. So the only way you get a positive, though, is H is negative 1. And then 3 units down. Oh, I should have put up here minus 3 so you can see it. And then 3 units down. K is minus 3. And I'll show you the math behind this, right? Again, the formula is, the parabola is A x minus H squared plus K. So what does that give us? Well, the parabola P is equal to, the parabola is still congruent, okay, to y equals x squared. So the A is still having a value of 1, but in this case it's negative 1. So negative. You have your brackets, x minus H, and our H is negative 1 squared, minus the K, minus 3. So let's write a nice cleaner one. And notice how these two negatives right here and here are going to give you a positive. Okay? So again, you see unit left here, and you expect to see a positive there. But in reality, it's because H is actually a negative number. But it's just a negative and a negative make a positive. All right, and last one. Has a vertex 0, 4 and opens up. All right, again, vertex 0, 4. This right here is our H, and there's our K. Opens up means A is positive. Because it didn't talk about any stretches or compressions or anything, it's still positive 1. A is positive 1. So then we have our parabola. Parabola is equal to A x minus H squared plus K. So just fill in all your unknowns. So the parabola, and I'm calling it P, like the parabola, it's because it told us P, by the way, okay? So, like, that's why I'm putting P here. Otherwise, yeah, you can write y equals, or you can write P of x. It's all the same thing. So the parabola is A, so in our case, again, it's 1. X minus 0, H was 0, squared, plus 4. So let's clean that up. That's P is, well, 1 times anything. You don't have to write the 1. X minus 0 is just x squared. So you actually don't even need these brackets. Just x squared. And then plus 4. And there's your final answer. Okay, so this is a longer lesson. So please do the homework, okay? I'll be back in class. You can ask me for any help on this stuff. But that's the end of the lesson. Thanks.